Hello, friends. This is a question and answer session for the HAZOP training course conducted on 10th January 2026. It was a wonderful session, very good response. A lot of participants participated. We had received a very good feedback after that also. And people requested us to just prepare a video of all the question answer which we could not respond during the session. So as a commitment, we are starting this question and answer session. This may be in 6 to 7 parts. Step by step, we will send it. So this is the first part today. So before starting, I hope that you have already subscribed this channel, and I humble request to you that to click the bell icon for receiving the regular notification for the various new courses and new videos and new updates about our HSC Process Safety Academy and about this channel. So, uh, just giving the brief of the session. So, this session, PSA01 free 1-day HAZOP training course conducted by myself. This was conducted on 10th January 2026, and I have shared this link in this course presentation. This course presentation, complete presentation in one set will be uploaded on the video YouTube also. And of course, there is a YouTube link for the HAZOP session, which was conducted on the 10th January, which is already shared here. So you can use this link. This will also be shared in the description of this particular video. You can go to the description and you can click to see the our full 1-day session on the HAZOP training course. So we received total 66 questions. So we will answer all the questions one by one. So in the first part, we will try to answer 10 to 11 questions. So we are starting with the first question, which refinery explosion was referred to in the CSB video? Can you share the link? So this was the question. Actually, we shared one CSB video for the explaining the requirement of the HAZOP study, why HAZOP study is required. And actually, in that video, there was a slight modification. Actually, modification was related to bypassing the instrument for the maintenance. So that was the modification was done. So this is related to that video. So you can see the link in this video also, and we will share this link in the description of this video. So you can go to the description and can check the video. Now, second question was, what is the purpose of PESO guideline? So actually, what is PESO? PESO is Petroleum and Explosive Safety Organization. It is a government body, and guideline ensures safe storage, handling, transport, and use of the petroleum, explosive, hazardous gases, and hazardous chemical in India. So they are mainly for the statutory compliance and licensing, not detailed process hazard analysis. So basically, the objective of PESO is to just ensure the compliance of the PESO guidelines for the installations. With installations related to explosive, chemical, petroleum, gas cylinder, installation of static modified pressure vessels, ammonium nitrate rules, and petroleum. So basically, all these installations we have to obtain the license from the PESO department when we install. In general, we can say flammable and explosive tank farm license we have to obtain from the PESO department. And there's minimum inventory level or threshold quantity beyond which if we store, we have to take the license. So basically, applicable act and rules in the PESO are Explosive Act 1884, Petroleum Act 1934, Gas Cylinder Rules 2016, Static and Mobile Pressure Rules SMPV, that is Ammonium Nitrate Rules, Petroleum Rules 2002. You can find all these rules on the PESO website. So you can go to the website and you will find the acts and rules there. So please refer the PESO websites for detailed acts and rules. Now let us see what is the flammable liquid petroleum-based liquid threshold quantity above which we need a license if we are storing the petroleum flammable liquids. So we know that petroleum class as per the PESO is class A, class B, class C, and excluded petroleum. So basically, these are categorized based on the flash point, which we discussed the definition in the HAZOP training course. So class A is less than 23 degrees centigrade. This is as per PESO, that is Indian guidelines. So we follow the Indian standard. So class B is flash point between 23 to 65 degrees centigrade. Class C, flash point between 65 to 93 degrees centigrade. And all the chemicals, combustible chemical above the flash point 93 degree is considered as excluded petrochemical. Now, for class A, threshold quantity means if we store 1 kilo also, so we need a petroleum license, which is mandatory. For class B, if we store more than 2500 liter quantity, so we need a peso license. For class C, if we store more than 45,000 liter, we need a peso license. And for excluded petroleum, there is no limit. So peso approval is required if there is a bulk storage, otherwise not required. Now, here regarding threshold quantity, it doesn't mean that we store, but means that we have the container of this capacity. Suppose we have the process vessel and we yes, the design of the process vessel, capacity of the process vessel is 2600 in case of class B, so we need a license. If design capacity of the vessel is 2400 uh, in class B, so we doesn't require the vessel license. Now, second question comes, if we have the capacity of 2600 and we are storing only 2300, then license is required or not? So answer is yes. As per the PESO guideline, if we have the capacity 2600 and we are storing 2300, so license is required. So whatever capacity we declare and design capacity in case of containers, in case of drums also, whatever capacity we declare, that is considered as a maximum capacity to be stored. And based on that license requirement, we have to decide it. So examples of class A is petrol, naphtha, class B, kerosene solvent, class C, light diesel oil. These are the few examples of class A, class B, class C chemicals. Now, in the second question itself, flammable chemical which are non-petroleum solvents. The same flashpoint guidelines, 20, less than 23, 20 is a class A, 23 to 65 class B, 65 to 93 class C. So typical examples are in the class A, we have the acetone, methanol, toluene. In class B, ethanol, IPA, class C, higher boiling solvents. So here also, threshold quantity, alley bulk storage for the peso approval is required. It may be 1 kg, 10 kg, 100 kg. For class B, same as the petroleum solvent, that if capacity of vessel capacity is more than 2500 liters, so license is required. For class C, if capacity is more than 45,000 liters, then this license is required. So PESO treat them equivalent to the petroleum class A, class B, class C. So there is no difference between petroleum and non-petroleum solvents. All similar for with reference to the license requirement and classification in ABC. Next comes flammable gas. What should be the threshold quantity? So, like in previous handled as per flashpoint evidence, so here gas cylinder rules is followed. So, defining the threshold quantity for the flammable gas, we have to follow gas cylinder rules 2016 as an SMPV rules. So, both are applicable because gas cylinder rules give the storage, handling, transportation, use related guidelines, and SMPV gives construction of the pressure vessel. So both combined, we have to see when we refer legal requirements or legal compliance for the gas cylinders. So there are different type of gases like LPG, propane, butane. The threshold quantity is 100 kg. If you so more than 100 kg at any single location or in single, you can say boundary. So vessel license is mandatory. Now here boundary or facility means normally if we have single GST but we have multiple plots, so that comes as a single facility. If we have one GST number in one facility, second GST number in second facility, so that is considered as a two different facility. Similar thing we can identify through if we have one factory license for 5 to 6 plots, so it comes under single facility. So like in we have suppose 5 to 6 plots, and each plots we use 25, 25, 25. So it comes to 6 plots means 150 kg. So in that case, if it's a one factory license, 6 plots, 25 into 6 means 150 kg storage. So we need a license. So like this, we have to analyze it. In case of hydrogen, any quantity, we need a PESO approval. Acetylene, if more than 25 meter cube, we need a license. In case of CNG, PNG, any cascade station, cascade storage or stations, we need a PESO approval. Cylinder storage For any gas, if more than 10 cylinders, suppose we have a combination of cylinders, like we have LPG, we have acetylene, we have propane cylinder, we have butane cylinder. So in that case, if process is number by more than 10, even though say LPG having 10 kg or 50 kg, other has 10, but if number crosses more than 10, so we need a PESO approval in case of combination of the cylinders. So this is a basic requirement. In case of explosive, uh, for threshold quantity, we have to refer the Explosive Act 1884 and Explosive Rule 2008. So any explosive, any quantity, we need a PESO license. For fireworks, small consumer quantity, PESO plus local authority. Ammonium nitrate, more than 100 kg, so we need a PESO license. So these are the basic requirements. So this is the basic understanding of the PESO and threshold quantities for requirement of the license. Now question 3. Are these guidelines specifying pilot scale HAZOP requirement? So answer yes in general. So pilot scale process are full process in miniature. We can say it's a micro level of complete process. So like full scale systems, they involve flow of material, paper, information, sequence of plant operation. HAZOP is applicable to any system, whether full scale, pilot scale, batch or continuous. So our answer to this question is yes. In case of pilot scale, also same has a requirement. You can follow same procedures. So basically, normally we follow IEC 61882 for the HAZOP. So you can follow same for the pilot scale also. So HAZOP applicabilities can be used to identify weakness in the existing or proposed system, useful for analyzing different operating states, startup like standby, normal operation, shutdown, emergency operation, all these. For all these, HAZOP is applicable or required. Can address non-operational conditions like storage or transport of materials at pilot scale. That is also possible and required. Applies to batch, unsteady state, or continuous operations. Any type of operation, either is a small scale, major scale, pilot scale, everywhere HAZOP is required. It is mandatory as per Factory Act also and different acts in India. Now, for the question 4. Question 4 is what is IS 15656 2006? That is the Indian standard. So, basically, this Indian standard is related to the risk assessment guidelines. So, IS 15656 is the Indian standard title Hazard Identification and Risk Analysis Code of Practice. So, providing a framework for different risk assessments, identification, risk analysis studies. So, basically, a collective term that encompasses all activities involved in identifying hazards and evaluating risk at facilities throughout their life cycle to make certain that risk to employee, to public, or to environment are consistently controlled within the organization's risk tolerance. So, it's basically guidelines to identify the risk in different stages of process and different life cycle of the stage. Say life cycle, as I already discussed in the our HAZOP session, that as per IS life cycle, it's pre-design, design or modification, commissioning, operation and maintenance, decommissioning, and shutdown. If we see international guidelines for stages of the project, so it start with the concept selection, then basic design, detailed design. So if we compare with IS, so we can say concept selection is a pre-design, then concept selection is not considered here, then basic design is a pre-design, then design modification is a detailed design, then installation is not considered here, but we can consider in the commissioning. So installation and commissioning, two stage in the international level, can be combined in the commissioning, operation, maintenance, decommissioning, shutdown, or demolition also can be considered like in international guidelines. So the lifespan of the process is extend from the conceptual stage to the final decommissioning or decommissioning and demolition. So life cycle is very important for any projects. After the life cycle, if we continue same plant, so we have to follow a few guidelines. Like we have to revalidate all the equipments, we have to revalidate the process through the HAZOP, we have to check the performance and further life of all the equipment. So these few things are required. So validation is required before continuing after the life cycle. Now, each stage of the plant life cycle may involve general hazards common to multiple stage and stage specified hazards unique to the phase. So in case of hazards, normally when we say what is the impact on human being, impact on the environment, asset, and reputation of the company. These are the four ultimate consequence or parameters which we through which we measure the hazards of particular activity. So as per IS 15656, which identifies various which identify various hazard identification risk analysis techniques suitable for application at different stage of the plant. The recommended technique for each stage are provided in the table one of this standard. So in case of pre-design, all are the general requirement. We have to see, check our process requirement, and based on it, we have to finalize what activity is required for particular life cycle stage. So if we consider a life cycle stage pre-design first, their hazard indices, that is one requirement identified. Preliminary hazard analysis, what if analysis, and checklist. Normally in process industries, we follow what if analysis and checklist, or otherwise PHA, process hazard analysis, or if we want to do in more detail, so initial HAZOP. So these are the basic requirements. In IS 15656, HAZOP is not specifically mentioned, but we can mention at some stage or not mention in some stage. So on a design modification, yeah, it is there. In the later stage, construction, commissioning, it is not mentioned, but in case of risk assessment, we can follow the process risk assessment through the HAZOP. So, in the second stage, design modification, process design checks, and use of checklist. That is the one step. First, one method or tool. Second tool is HAZOP study. Third is FMEA. So HAZOP is applicable for the process. Checklist applicable for all the industries. HAZOP is applicable for process. FMEA, failure mode effect analysis, is mainly for the equipments, instrumentation, so electrical industries, mechanical industries. What if analysis is applicable for all. Faulty analysis, of course, inventory analysis based on the requirements. Suppose we want to check the reliability, so these are applicable mainly. In case of construction stage, checklist and what if analysis are normally preferred, but international level, we normally do the other also. So commissioning, of course, checklist, plant safety audits, what if analysis. Normally now, plant safety audit, we can refer to the PSSR also. So PSSR and plant safety audit for this commissioning stage are the same thing. But nowadays, we call it as a pre-startup safety review, PSSR. Operation and maintenance. So plant safety audits, what if analysis, checklist. Of course, here HAZOP is must. We do the recycling HAZOP here, so that is must. But it is not mentioned in the IS 15656, so we can do it. Audit is also applicable for all the industries. What if and checklist. Checklist mainly for the monitoring activity. So audit and monitoring both are the part for the sustainability of the safety system in the company. So that is must. Decommissioning, shutdown, checklist, what if analysis, of course, same thing. Both are applicable. Now, question 5. What is IHA? Initial hazard analysis. It is a preliminary high level hazard identification method used in the early project stage, concept, feasibility, basic design. So it can be done through checklist also. So focus on identifying major hazards, hazardous materials, and high risk operation. So we can say it's a macro level hazard analysis. Flammable chemicals are there or not? Radiation hazards are there or not? What are the types of hazards in the project? Then uh, then different say explosion hazards is possible or not. All this we have to identify through uh, initial hazard analysis. It helps decide which detailed PHA techniques are required in later stage. Of course, if it is a process, so HAZOP is must. Loop pump may be required based on the reliability and severity of the project, FT, etc. So typical input required list of major hazards, potential accident scenarios. So in case of major hazard, we can say we need a list of the chemicals to be used and storage quantities. Potential accident scenarios that can be decided through PHA or IHA. High level risk and ranking, of course, that is through the risk matrix. Recommendations for further studies, of course, through in the IHA we can recommend which studies are required in the further later stage of different stage of the project. So where it fits earlier than hazard and HAZOP, of course, often required by the regulators and corporate PSM systems. So mainly in India, we say driving factor is corporate guidelines. And globe level, world level, of course, corporate guidelines are there to conduct the IHA. Question number 6. can risk be reduced by severity reduction, not only likelihood reduction? So question is that because we have the severity and likelihood, so normally we reduce the risk by introducing the various controls, that is through likelihood reduction. But can risk be reduced by the severity reduction? So answer is yes. Let us see what are the probabilities for that and how it can be done. So basically, if we see the risk formula, so risk is defined as a product of likelihood and severity. So we can say risk is equal to likelihood into severity. From this formula, everyone can say yes. For the question, answer is yes, because if you reduce likelihood, risk will be reduced. If you reduce severity, risk will be reduced. It's a multiplication. So therefore, risk reduction can be achieved by reducing the likelihood of an event and or reducing the severity of its consequences. In practice, more than 90% of risk reduction is typically achieved by reducing the likelihood through controls, safeguards, and procedures, trainings, all these things. Now, let us see how risk reduction can be done with the help of severity. So it's less common, but of course, it can be achieved primarily through the design change or inherent safer design techniques. So severity reduction is not usually achievable through the operational procedural safeguard alone, but it can be achieved by design change, by change in the raw material, by change in the equipment, change in the heating media, or using the inherent safer design checklist. In inherent safer design checklist, all these points are available so that you can refer and you can reduce the risk by reducing the severity. Question 7. Is frequency also a definition in process safety management? Yes, frequency is a fundamental parameter and is often used interchangeably with likelihood in the risk definition. The frequency is number of the occurrence of an event per unit of the time. So I think this is one of the KRA also, key performance, KPA, we can say KPA, key performance analysis of the employees or department of the company. So we normally, if you recall, we normally check the frequency rate of the company. Normally, if you go to good companies, corporate companies, so on the gate itself, you will find the numbers of accidents in the last 1 year. What was the frequency rate? What was the severity rate? Frequency rate for the employees, for the contractors and whole companies. So frequency, of course, it is a parameter. So frequency is a key component of the risk assessment, where risk is equal to frequency into consequence. We have seen in the previous questions also, question number 6, that is a multiplication of risk is a multiplication of frequency, or we call it as a likelihood also, and consequence, which is severity. So frequency is applied in various PSM tools, including HAZOP. In all the risk assessment techniques where we use the risk matrix, the frequency is a part of that, because risk matrix is a part of frequency and severity. So one part is frequency. So of course, in case of layer of protection analysis, to quantify initiating event, frequency and protection layers are very important. So we normally find out the failure frequency there. So quantitative risk assessment, also frequency is one of the important, because there we calculate we do the frequency analysis, consequence analysis, all this we do. To calculate the numerical risk level, we normally use the frequency term. Incident investigation, frequency is used to describe how often a type of incident, near miss or unsafe event occurs. So when we do the company or analysis of the incidents monthly, quarterly, annually, so we use different parameters like frequency rate of the employees, frequency rate of the contractor, whole company employees, frequency rate for the near miss, for major accidents, Mandel's loss, all this we can calculate to the. So their frequency is applicable. Now question 8, how can all process risk be identified? What is the best tool? The term process covers the entire facility, from raw material receiving to final product dispatching, including receiving and transferring raw material, chemical reaction processing, storage handling, utilities, waste, and other supporting operations. So question, if you go back to the question, how can all process risk be identified? So that is, the process is this one part. If you consider process, so we are receiving the raw material, we are unloading drums, loading drums, we are in after completion of the process, we fill the drums, we sometimes fill the tanker. So these all parts of the process. So no single tool can be identified for all the process risks. The best approach is a combination of multiple hazard identification and risk analysis tool. So in case of our process, core process support, we say we are unloading drum or unloading the tanker, loading the tanker. So in that case, we normally use, in case of tanker, of course, we can use the HAZOP, but in case of handling the drums, we normally use, we can say, HERA or GSA. So as we require. So basically, GSA specifically non-routine jobs. So normally is used for the maintenance activities, but some companies say we do the GSA, but normally they are doing they are doing the HERA. So HERA, GSA, and HAZOP. It's a combination which covers the non-routine job, routine job in the process, non-routine job in the process, and maintenance activity. There are many, I think we can say 25 to 30 different tools for the process risk assessment, starting from HAZOP, SOPA, LOPA, SAIL, QRA, BOTI, safety critical elements, FERA, FMEA, all different tools are available based on the requirement of the risk assessment. Question number 8. So these are the few tools you can see in the screen. It's normally risk assessment start with the hazard, then HAZOP, SEAL, SRS. SRS related to specification, SEAL. So basic what minimum documents are required. You can see from this diagram. So then we have the safety critical element, performance standards, FERA, QRA, ERA, ALAP, all these are the minimum safety cases, but maybe you can say we have 25, 30 different tools depending upon the requirements. Question number 9. What is the design intent? So basically, complete HAZOP is based on this particular word, design intent. So normally we do the HAZOP for the design intent. We see the deviation outside the design intent. So design intent describes how the system is intended to operate safely. So it's a basic, we can say, boundary of the process, boundary of the particular operation, boundary of the particular activities. So with including operating limits, control philosophy, and assumptions used as the reference point in the HAZOP. So the design intention, the expected operating range, and purpose of the node. Say, suppose we have distillation in distillation column. So here our design intent, we can define that if we start with the pumping of the feed, so we are transferring, feeding the solvent A in the column. It's a mixture of ABC, we can say. We have the ABC, A or B mixture, or say ABC mixtures. We are feeding. So our design intent start from the transfer of our this mixture from a previous vessel through this pump to this column. So that is the first boundary limit. So we have to define the boundary limit first for the design intent. Then what are the operating parameters in the column? So parameters are like temperature, pressures, all these parameters. That is a design intent. So any design intention includes our streams and operating parameters. And assumptions we have made, or control philosophy. Suppose we have to maintain the pressure at 70-degree pressure at 70 mm water column vacuum, or 70 mm HG vacuum, mercury vacuum, or temperature at 140, 130. So these are the part of the design intent when we explain any stream's design intent. So any condition outside the range is treated as a deviation. Suppose we say we have to maintain the distillation temperature or column top temperature 40 to 45. So anything below 40 or above 45 is outside the design intent, and that is a deviation. A good design intention links directly to the drawing and includes detail about the equipment, materials, conditions, flow, and control. So a good design intention means if we explain, we give the name of the number of tag of the equipment, we give the MOC, we give the feed materials composition, product output compositions, residue composition, any other stream output composition, flow, feed flow, or product flow, residue flow, and what are the controls involved, then it's a good design intention. It describes not just the equipment but what should happen in this in that section of the process. So in case of say, suppose there are a few examples is given styrene tanker unloading. So design intention here is styrene transfer from road tanker to storage tank by storage tank B101AB by unloading pump P101DE. Second thing, storage of styrene in storage tank. So these are the two design intention for this particular node. So P&ID number, storage tank number, and what are the basically we can add here temperature and pressure condition of the storage tank. So it's if it is ambient, so we have to write down ambient temperature and pressure. These are the few things. If we have a breather wall on the tank, we can describe the tank have the breather wall also. Second, styrene transfer operation. So transfer of styrene from storage tank to process area by styrene transfer pump KP101GH. So this is the basically design intention of second node. So likewise, we have to explain in detail the process parameter along with the boundaries. Now, question number 10. HAZOP and HERA, what is the main difference between these things? Yeah, good question. Always getting confused. As I said earlier, HERA is also part of the HERA activities are part of the process, but like unloading of drum, shifting of drum, handling of drum, these are not the hardcore process, but connected process. So risk assessment of all this activity we can do through HISA, but reactions, unit operations, transferring operations, storage, all this risk assessment we do it through HAZOP. So let us see one by one. Full form of the HIRA is hazard identification risk assessment. Sometimes we call it as a hazard identification risk analysis and assessment. HAZOP, hazard and operability study. Actually, in HAZOP, this is the basic, we can say, full form when HAZOP was introduced. But now there are different HAZOP. So control HAZOP is for different purpose. E-HAZOP is for different purpose. So accordingly, we can check the full form. Focus. HERA focus is overall workplace and process risk. So we can say it's a macro level. HAZOP, process deviation, and design intention. So in detail, we do one by one stream here for the HAZOP. So level HAZOP, of course, HERA is a macro level. HAZOP details, it's a micro level process. And in HERA, we use the risk matrix based, whereas HAZOP is a guide word based. That is the basic difference. So in HERA, we may require a small team or individual can also do. But in HAZOP, we need a multidisciplinary team, all are involved. So in case of HERA, operation team, maintenance, operation engineer, maintenance engineer can sit together and do the HERA. But for HAZOP, we need operation, process, quality, mechanical, electrical, project team, commissioning engineer, process, plant engineer, all these minimum required safety engineers, these are required. So HERA, basically from HERA, we prepare a risk register where from HAZOP brainstorm session, we prepare a HAZOP worksheet. So records of HERA are maintained in the risk register and records of HAZOP maintained in the worksheet, HAZOP worksheet. So HERA basically required periodically as needed. So same, we can say cyclic HERA, and as and needed means whenever there is a change or modification. The same is applicable for the HAZOP during the design stage, MOC. So actually HERA and HAZOP requirement applicable same because all the stages of life cycle we need a HERA and HAZOP. Global level in India normally we call it as a HERA, but at world level normally it is a we can say risk register through HAZID or other techniques. So mandatory requirements are for the HERA ISO 45001 or Factory Act, whereas for HAZOP, of course, IEC 6182, OSHA PSM or HSE UK PSM. So these are the all the questions which we have completed today. So this is a part one of the response. Now, second part we will continue and we will share. So you can refer that also. So thank you very much. I hope once again reminding you that you have, if you have not subscribed, so please subscribe our channel. Please click the bell button for the notification for receiving the very different new uploaded videos. So please continue. Please be connected with us. We have a lot of upcoming programs also every month, one free program. So throughout year in the 2026. So please remain with us. We will have a lot of good videos in the future also. Thank you very much. Have a nice day.